So today we're going to be talking about the circumference and area of circles. And specifically, I am going to go over how to calculate these in what we call exact form. So before we get started, I want to do a little bit of a review of some of the properties of circles. There's the area and circumference formulas that you may already know, and then there's also some labels of a circle that we want to consider here. So first of all, of these options that we have in the bottom left, we want to first identify what the area is. And the area formula is actually pi r squared. Next, we want to identify the circumference formula, which is 2 pi r. And then we have some labels to put on the circle here. I'll start with the distance that is around the full circle, almost like the perimeter of the circle. This is what we call the circumference. And then we have this distance that goes across the circle through the center of it, and that is the diameter. And then last we have the distance from the center of the circle to the edge, which is the radius. And the radius is always going to be half of the diameter. Okay, so I want to next talk about the two different types of problems that you're going to see on this unit test. The first one that I'm going to go through is an example like this. What is the circumference of a circle with a radius of 10? Use 3.14 for pi. The second type is what is the exact circumference of a circle with a radius of 10? Now, if you notice, the difference between these two problems is what I have in bold, whether we use 3.14 for pi or whether we calculate the exact answer. The thing that I'm actually finding is the same for both. I'm finding both the circumference of a circle with a radius of 10, and I'll show you how our answers are going to look a little bit different. So for the first type, we're going to use 3.14 for pi. I have the circumference formula here, and I'm going to plug in 3.14 for pi as it says, and I'm also going to plug in 10 for r, the radius. So the circumference is 2 times 3.14 times the radius of 10. And I want to point out, I know many of you have a nifty little pi button on your calculator. Do not use that button. They want you to use specifically 3.14. That button actually goes on past 0.14. It's 3.14159, etc., etc. And by using only 3.14, this is going to help us round our answer. And so this one is kind of one that we can do in our head. So 2 times 3.14 is going to double everything. It's going to be 6.28 times 10. Multiplying by 10 is just going to move that decimal over. And so we get the circumference to be 62.8 centimeters. Okay, so now we're going to find a different type of problem. We're going to find the exact circumference of the same circle. So what exact means is we're not going to plug anything in for pi. We are going to leave pi alone. And the reason for that is pi, when we use a calculator, is a number that goes on forever. And so we eventually would have to round it if we plug something in for pi. But I'll show you what it's going to look like when we leave pi alone. It's going to look a lot simpler, actually. We're going to have the 2 in the front multiplied times the symbol pi. Remember, we're not going to plug anything in for pi. And I'm going to plug in still that radius of 10 for r. And these are all multiplied together. I have 2 times pi times 10. And you can multiply things in any order. So I'm going to go ahead and multiply 2 times 10 to give me 20. And that pi is still sitting there, so we don't want to lose it. But this is our final answer when we are finding the circumference in exact form. Now, I want to point out the answer is not 20. The answer is 20 times pi. This times pi part is really important because pi is a number that is about 3, and so that means the circumference is not 20, it's going to be over 60, like we got in the previous example. So just to reiterate, when you have a problem where you need to use 3.14 for pi, you're going to get an answer that's written as a decimal. We got 62.8. And then when you have where they're asking for the exact answer, then you're going to have something that usually includes the value of pi in it. And these two numbers are the same thing, except for this is a rounded version of what 20 times pi would be. Just two different ways to write the answer. So let's try this example problem. We need to find the exact area of this circle right here. And so I'm going to identify which formula to use. Since I'm finding area, I'm going to use pi r squared for this formula. Oops, forgot my pi. And notice how it says that we need the exact area. We are going to leave pi alone because of that. And so I'm going to plug in nothing for pi, and I need to identify what the radius is. So looking at the graph, you can kind of mark on there where the radius is and count how many there are. There's 3 boxes there. And so I'm going to plug in 3 for our radius and square it. And I want to point out that square is only attached to the 3. It's not attached to the pi. So we're just going to do 3 squared, which is 9. And we typically put, kind of like with variables, we put the number in front of symbols for some reason. I don't know what mathematician decided that's just kind of the standard way of doing it, but that's it. And this is our final answer, 9 pi, or 9 times pi. Okay, next we have a diameter of a circle is 12. What is the area of a circle? Use 3.14 for pi. Okay, so I would highly recommend drawing a quick sketch in your notes of something like this when they don't give you a diagram. The diameter of the circle is 12. So the diameter is the full distance across, and that distance is going to be 12. The area is going to be pi r squared, so we're going to use that formula, pi r squared. And now in this problem, am I going to leave pi alone, or am I going to plug something in for pi? Well, as it says, we want to use 3.14 for pi. So follow those instructions there. We're going to plug in 3.14, and the radius is not 12. The radius is actually going to be 6. And that's why it's kind of helpful to draw these out. Sometimes people just want to pull a number from the problem and plug that in. But when you draw it, it sometimes avoids mistakes. So 6 is the radius. And we're going to plug this into our calculator. For the area, I'm getting 113.04. And there's no instructions about rounding it or anything, so I just want to plug that in as my final answer. We'll do another challenge problem here. It says the area of a circle is 169 pi. What is the radius of the circle? Now the approach to this problem is going to be a little bit different, but I'd still encourage you to use the information in the problem as a hint if you don't know where to get started. So we have the area, and so I'm just going to write out my area formula. Area equals pi r squared. And I want to plug in the information that they give us to see if we can figure out what we need to find. And if you notice, the area is 169 pi. So I'm going to plug in that whole thing for my A value. A lot of people just write 169 for some reason, but that is not the same thing as 169 times pi. And then it doesn't say anything about whether to do this in exact form or to plug in 3.14 for pi, but I'm going to show you how this is going to make things a little bit simpler if we don't plug in 3.14 for pi. So, and then we're trying to solve for the radius, so we don't know what the radius is. That's what we're going to try to solve in this equation. So we want to get rid of this pi in front of the radius, and we also want to get rid of this square. The first thing that you're going to want to get rid of is the pi. Now, pi is a number. Pi is 3.14, and so on. And so normally when you have a number in front of a variable, you would divide it to continue to solve for that variable. And so I'm going to divide both sides by pi, and conveniently that actually cancels it from both the right side and the left side. So we're left with 169 on the left side and r squared on the right side. Now, how do we get rid of this square? Oftentimes in geometry, you're going to have to solve by getting rid of a square, and so you have to remember that the opposite of squaring is taking the square root. And so we're going to take the square root of both sides to cancel that square, and the square root of 169 is 13, and those canceled each other, the square root and the square, and so that is our radius. We'll do one last kind of challenge problem here, and the question is, the circumference of a circle is 11 pi. What is the area of the circle? So the question is, what is the area? So I know I'm going to have to use that formula. Area equals pi r squared. But I don't know what the radius is. They only told me that the circumference of a circle is 11 pi. So how can I figure out the radius if I know the circumference? Well, we can kind of take a similar approach to what we did in the previous problem. Let's use the circumference formula, 2 pi r, and see if we can solve for the radius there. So the circumference is 11 pi. I'm going to plug that in for my c value. 11 pi equals 2 pi r. Now we're going to get rid of this value in front, or these two values that are multiplied by the radius. We have 2 and pi that we can get rid of, so I'm going to divide 2 pi by both sides to cancel it. And we are going to also cancel the pi on the left-hand side, which is nice and convenient. And I'm going to go ahead and reduce 11 divided by 2 is 5.5. And now I have a radius of a circle. The radius is something that we can plug in to now find the area. So the radius is 5.5. I'm going to plug that in. And this one also does not tell me any information about plugging in 3.14 for pi or doing the exact form. But because there is a pi involved in the original question, that's sort of a hint that you should leave pi alone. But it will tell you, a problem like this one will often have multiple choice options for you to pick a solution that has a pi involved. And so I'm going to plug this into my calculator. 5.5 squared is 30.25. And again, this is being multiplied by pi. Typically, we write the pi second. And this is the exact form of the area of this circle.